Thank you, everybody, for joining us today. My name is Peter West, the CEO of West Networks, and with me is Travis Durick, product manager for North America. And this is well over 2 years now of doing these monthly webinars. And last month, 2 months, we've been talking about SpeedFusion Boost. We've been talking about different Starlink integration and OneWeb integration. And we've actually got a lot of feedback that we're not deep diving into the actual how to set these things up. And so I wanted to try to do that. Now, I'm going to preface this a little bit. First, at the summit, little blurb there, peplinksummit.com, we have a 4-day event that covers SpeedFusion and InControl. So I'm going to try to shove an entire day of training in 1 hour. And so please bear with me, and I'm going to do the best I can. If this is super popular, please reach out to Travis and say, do it again, and we'll try to get more in this. But they gave me a bunch of tasks, and I'm actually not even going to review them with you because I want to make sure that we can spend dedicated time working through each of the tasks they've given us. And once again, if this becomes a part 1 and part 2, I'm okay with that if Travis is. So,
Yeah.
but the idea here is we have the Peplink SD-WAN infrastructure we call SpeedFusion. And if you don't already know, SpeedFusion is our Peplink's bonded VPN SD-WAN solution. What's really cool about SpeedFusion is that it is a 256-bit AES 256 TLS 1.3 per WAN bonding solution, or VPN. What that means is if I have 4 WANs on the left side and 2 WANs on the right side, I'm creating 8 individual AES 256 TLS 1.3. And Travis, your job as the product manager is to hold me accountable for what I say, because I'm pulling this out of memory. So we will have 8 unique encrypted tunnels in that scenario. So when you think about the security of that, it's pretty neat. And it only costs 4% more than an IPsec tunnel. So an IPsec tunnel uses about 14% overhead. So if I have a 100 meg circuit and I do a speed test, I should be getting around 86 megabits per second. SpeedFusion is an 18%. So you're paying 4% additional for all the features and capabilities of SpeedFusion. And so that's going to take you to 82 megabits per second. Now that math is pretty funny because some people have complained about a decrease in speed on SpeedFusion over their WAN links. And when you start to play around with the speed calculations and then the overhead calculations, you'll see why sometimes when your internet speed is slower than the capacity of your SpeedFusion throughput, that you might actually see a small decrease in performance. But that's by design. And by that design, you're getting an amazing encryption. You're getting packet-based bonding. We're not doing session-based load balancing over SpeedFusion. We're doing packet-based bonding. And so and then we add features like WAN smoothing, forward error correction. And then we have technologies like hot failover and dynamic weighted bonding. And so forward error correction has 3 modes: adaptive, low, and high. Adaptive uses between 6 and 20% overhead on top of bonding overhead. So I'm using 18%, and then I add forward error correction, which adds bits into the program, which is going to add overhead to that at 6 to 20%. Low, FEC low is 13%, and FEC high is 26%. And so once again, those are additive calculations. WAN smoothing, which is something that people use a lot to reduce jitter and latency. So WAN smoothing is designed to reduce latency and jitter. That has a cost of between 100 and 400%. So it's basically, think of it as like a RAID array of your WAN circuits. And so think of those as a RAID array on your WAN circuits. So if I have 2 internet connections and I do WAN smoothing, I'm doubling the parity. That's 100%. I'm only going to be able to have the aggregate capacity of whatever my slowest of the 2 links are, because I'm duplicating that data. And so sometimes that math can add up quickly. I've gone into people's networks, I kid you not, that are complaining about speed, and they will have 2 Starlinks with forward error correction high, WAN smoothing high. And they're like, why am I getting 6 megabits per second of throughput? And I'm like, because you have 400% utilization. Well, 426% plus the 18. So 400, what, 436, 442% overhead. And so these things add up. And it's not to scare you, it's to set a baseline of understanding. So what you're trading is bandwidth for a goal or a mission. And when I talk about SpeedFusion or SD-WAN or Peplink or anything that we build, we're building to accomplish a mission. If I'm trying to do jobs at a construction site, I'm not going to drive a Ferrari to a construction site. I'm going to rip the bottom right off the car. I'm going to buy a truck or at least something that has elevation that can go over the bumps. The same applies to when we design network infrastructure. We want to make sure that the networks we build are solving a mission. And so the idea is that if I'm doing a mission critical telemetry stream of 20 kilobits per second, and I need it to be the absolute lowest latency, no jitter, perfectly deployed, then I need WAN smoothing that. I want to send that data across all of those circuits. And then I want to make sure that whichever one, the first one to be received is the one that's received. Because I'm not trying to go for bandwidth. I want it to be perfect every single time. And that WAN smoothing at the maximum level is going to basically make that happen for the end user.
I was gonna say, like, if you're flying, if you're piloting a robot, you want that joystick control to get there, right? You don't,
Yep.
the video stream may not be as critical, but those controls, you gotta have that.
Yeah, it better be perfect, right?
Yep.
And the same goes if I'm doing a broadcast at a mission critical environment with in a congested network at a sporting event. Maybe I need to do FEC high. I'm going to sacrifice that 26%, but I'm going to make sure that uplink, that video stream, is delivered appropriately. And so the first thing to know about SpeedFusion is that the technologies are there to support the mission. And we build based on that. And so there is no one size fits all. What we're going to do today is not a configure it like this and it'll always work. That simply doesn't work. Or if you need it to, then 8 Starlinks, 8 5Gs, an EPX router, and I promise you, you're always going to have the connectivity you need. But not everybody can do that. And so we design the network based on the mission. And I constantly challenge people that call me when we talk about these things, that's what we're doing. We're designing for the mission. So
yeah, what you just, I love what you laid out there because, you kind of like laid out the ceiling of like, if we've got these things, we can basically do anything anywhere, right? And, and so then you're just cutting the recipe down to support the mission that person needs, right? And so, but yeah, I love that because yeah, if you've got that, you've demonstrated what's possible.
Right. And then you have technologies like hot failover. Hot failover is more of a feature than a technology. It's going to let you basically use WAN priorities to fail over from one internet link to another. So a good example of this is, let's say you are a point of sale retail environment and you have a broadband circuit. But when that broadband circuit drops, you might lose phone calls, you might lose point of sale transactions that are happening right at that moment. Or there might be like a 30 or 60-second delay. And people go, oh man, I actually had a real life scenario where this happened just a couple weeks ago. A customer saying, yeah, I bought one of your BR1 routers. It doesn't work the way you say it's going to work. And they basically plugged the BR1 into the cable modem as a WAN going into the LAN of the cable modem, and then had another Wi-Fi set up on the BR1. And so they so whenever their cable modem, they would unplug the cable modem and kick them over to the BR1. And so I got it fixed and programmed it the right way. But the idea is that hot failover uses bonding. So it has to go somewhere. And that's why Peplink has built SpeedFusion Connect, or you can use SpeedFusion bonding to your own site to be able to aggregate that point of sale transaction over your broadband and your 5G or cellular at the same time, but cost you very little cellular data. It's going to use that broadband circuit 98% of the time. That 2% of the time when the broadband fails, it's going to seamlessly move over to WAN or to the 5G. And that's called hot failover. And so I'm going to demonstrate those technologies and how they work. And then another feature is the ability to do sub tunnels or multiple profiles. So the idea of multiple profiles means that I could have bonded a hot failover. I'm trying to think of the best way I want to do this. A hot failover of broadband to 5G for my daily office network, right? I don't want to use the broadband unless the 5G goes down. But I could also have a profile that uses WAN smoothing over broadband and 5G for mission critical like voice applications. So in the same network, I could have all my regular internet going out the broadband and then failing over to 5G and live in the event that the broadband fails. But Teams and Zoom and FaceTime can all go over both of those circuits at the exact same time, ensuring really good uplink and downlink reliability using WAN smoothing. And so those mission critical voice and video applications are going to function really nicely. That's just an example. And so I'm going to show you these things today. Today, what we're going to do is we're going to go over the different ways to configure SpeedFusion, how those things play out, and then using outbound policies to configure them. And I'm going to do the best I can to fit this into the next 45 minutes. And like I said, if this is really successful, please email Travis and say, let's do a part 2. So the first is going to be split tunnel and tunnel deployments. So I have a B1 5G. So I've got a lab here. I've got a top and a bottom router. I've got my B1 5G connected here, and I've got 2 cellulars and a Starlink on the top one, and then my bottom one is, I believe, just has cellular and Ethernet. Yeah, so kind of got a couple of routers here to play with. I've got a synergized BR1 Mini 5G red cap, and so that's connected to my T-Mobile internet, and that's using that. I don't know if you know what red cap is. That's that reduced capacity 2x2 MIMO. So it's designed to plug into like an additional 4G antenna, allowing you to upgrade to 5G. So kind of fun there, just playing with some technology. And so the first thing I'm going to use this lab environment. And by the way, whenever we like play around with WANs, with the labs and the things that I do, or the Peplink Summit, I'm always playing around with these because it's sort of our lab kit, a switch, 2 routers, and a BR1. So you can play around with synergy mode, different WANs, etc. So the first thing we're going to do is we're going to create a multi-tunnel solution, exactly like I just described. So I'm going to connect the top router to the bottom router, and we're going to Starlink is messing up there, but we're going to bond. So we're going to have hot failover, and then we're going to have WAN smoothing, and then we're going to send our voice traffic over that WAN smoothing. So, okay. So let me go to SpeedFusion configuration. So first, you want to make sure those routers are set up. The other thing I would say, actually, I got to make sure I put this in there, is that you need to make sure you have unique profile names, or DNS, subnets. So if I'm going to create a SpeedFusion tunnel between these 2 routers, one router is 192.168.101.1, and my other router is 192.168.102. And then my voice VLAN is 10.2.102. And my voice VLAN on the other side, I thought was 101. So we're good. So we don't have any conflicting subnets between these 2 routers. So then I'm going to go to SpeedFusion configuration, enabled. I'm going to click add a new profile. So we have 3 types of profiles we can create: star, fully meshed, and point-to-point. Star is hub and spoke. So if I'm going to have a hub and spokes, I like star for most even point-to-point type solutions, because you have one unit as that hub unit that's saying, hey, this is where my fast internet is. It just in my brain, it works better that this is my hub versus a point-to-point. you're connecting these two. Now, point to point works really well if, especially if you have two public IPs and you want that locked in between 2 points, you can do that. And then fully meshed will connect every site to every site. So if I have 5 sites, that's going to use 4 tunnels on each router. And so some tunnel routers only come with two tunnels by default, and so you'd have to buy like a 5 SpeedFusion license to extend your routers to support 5 tunnels. So fully meshed will create a connection from every site to every site. This is really good, especially if you have direct dial phone extensions or you have like DNS and servers at other sites. Most of the time, with everybody moving to the cloud, I see Star is primarily used because you have like you might have a Fusion hub in Azure or AWS, and then you might have a data center in Atlanta or Texas or somewhere, and you're connecting back to those locations using those as your hubs, and then your branches are connecting into that. So for today, we're going to use Star. I'm going to choose my hub because all of my Starlink and 5Gs are on the top one. I'm going to use the bottom one as my hub. There's my public IP address right there. And I can just delete the other one. It's going to detect the interface IP. If you're being CG natted or you're behind a firewall, let's say you're a hospital and you plug in your router behind a firewall and you're natting to a public IP, sometimes this IP might be wrong. So make sure that this is the public IP address with 32015 and 4500 TCP and UDP going from a public into your private. That being said, and this is actually a good time to say this, is SpeedFusion requires one site to have a publicly accessible IP address on ports 32015 and 4500 TCP and UDP. I've had several customers where they go to create a tunnel and they're behind their perimeter firewall, and the perimeter firewall has IPsec VPN, which is port 4500. Then they port forward 4500 and it doesn't work. And so we could change that port, and I'll show you where to do this in the next page. But the default for Peplink is 4500 and 32015. And I recommend TCP and UDP, and you'll see why in a few seconds.
The other cool one here is when it says private IP addresses may not be reachable by endpoint devices. Sometimes they are, right? If you have private Ethernet or if you have private cellular circuits, sometimes having private IP addresses in there is actually valid, and you can combine those private and public links together in these profiles. So it can be different depending on what you've got in play there.
Definitely. And it also, like, I mean, when we're doing like private 5G bonding, we're actually connecting private networks. When we do like MPLS, or we're doing like say you have an MPLS connection and you're trying to add Starlink or 5G, one of those links is going to be a private IP address because that's your MPLS connection, or your private Ethernet connection. So you could actually, like, if I took an Ethernet line and connect it from LAN 4 to LAN 4, I could actually simulate like a private 5G and or private Ethernet, and then you would need the private IP of that WAN interface.
And
you can
that's kind of like that's pretty unique in general, like being able to bond a private circuit with an internet broadband circuit and keep it basically behaving like a private circuit still, or making a hybrid of both.
And it's crazy how like a lot of these quote unquote SD-WAN solutions, they require public IPs. They will not even connect if they don't have a public IP. Yep. And that to me is nuts. I mean, job security, because all we do is a layer 2, and I give out public IPs behind a Peplink. But it's so funny to me because we'll have like a Peplink router giving out a public IP to another SD-WAN router. And so it's like you need Peplink SD-WAN to connect the other company's SD-WAN, which I always find humorous.
I've been talking to like one of the biggest companies in the world for the last 2 weeks doing exactly that, giving their SD-WAN public IPs through SpeedFusion because they are not able to achieve it, right? Like, and so we're just Frankensteining their SD-WAN to make it work. And, it could be done a lot better if they just had Peplink in there, but we'll start here. That's fine.
But just slowly, right?
Yes.
But it is really funny because I get that a lot. And yeah, so it's pretty funny there. Check this show advanced it lets you see options. If you see that in any of these, especially as you're learning, click that box. Now, let's say you have two routers that you want to be distributed hubs. You could actually do disaster recovery and select another router to be another hub. So I can have it to where I'm connected to the data center East Coast and data center right coast, and then I can have this selected right here. That is not the same as HA. If I'm doing HA, then then you're only going to select the master router. And this is really important. That master router is going to mirror over to the slave, the same name, the same WAN IP addresses. So if I have HA, you're going to see a little yellow bar up here, a blue bar that says HA pair when you select an HA pair as the router. And then you're going to see, and you only select the master. So when you're in HA, it's important that you enable that configuration, that if you have configuration sync enabled, that you don't lose that you don't disable configuration sync if you have tunnels configured, because all those peers are connecting back to the primary router. And then when you fail over, the secondary router is assuming that it is the primary router. It'll say in master mode. And so you want to make sure that you don't make any changes until you restore a healthy HA state and then make changes. Next, then you can select your branches. So I'm going to select my B1 top. And once again, I can hit show advanced settings. That's going to stay there. And you can see here, add device and device filters. This is kind of cool. Let's say that you want to allow a VPN connection from somebody not in your organization. You can actually add their remote ID, pre-shared key, and their IP address, optional, and save. So I could say Travis and hit save. And I could add Travis. And Travis then would be able to use my pre-shared key and IP address and connect into my router. So his local ID just needs to be Travis. So this is a great capability, especially if you're migrating or you want to bring in somebody from a different organization. So
Yeah, our service providers share out resources to customers that way. They'll, isolate them by VLANs or routing domains and segment that still. But yeah, they've got the ability to let the customer have their own Peplink in their own in control account that they can manage, yet connect to yours and your account and not be able to manage each other.
Exactly. And so now we want to give it a name. So we can just say SpeedFusion demo. Now here we have dynamic links, which you can hover over here, allows individual links in the profiles to be dynamically enabled whenever both the hub and endpoint devices have pre-selected trigger tag that applied to them. You can have encryption. So this encryption will save you a little bit of bandwidth. So if you are super bandwidth sensitive, you can turn off encryption. And then you still have the benefit of the tunnel and the split packets, which still makes it pretty hard to intercept, especially if you have multiple WANs. But if you're going purely for speed or you're bonding to the internet, for example, I've got a hub here. If it's bonding to go out to the internet, I mean, you don't need to encrypt if your next hop is the internet. Like it doesn't make any sense because you're yeah, I mean, you're already SSL or, it's no less secure than just going out to the internet. If not, it's a little bit more secure because you are still getting that benefit of bonding. Okay, so you can turn off or on SpeedFusion or encryption based on your application needs. NAT mode. NAT mode is really interesting, and be careful with it if you don't know what that is. NAT mode lets you basically allows you to either have conflicting IP addresses on your peers or allows you to bring a peer into your network. And I've had two use cases with this. So one, we host bonding for people. So we have some B5000s. And then we have basically a CG NAT, if you think of it. I've got a large, /12 network, 172 network that we connected. And so customers can connect into our B5000 natted. They're going to get a 172 IP address, and then on their SpeedFusion tunnel. And then they go, so they could have 192.168.50. You could have 10 customers with 192.168.50, but their IP address will be 172.31.250.1.2.3.4.5. So you're natting them, so you don't have to worry about IP conflicts of the remotes of the pure router. The downside is it's one way. You can't go back easily. You can do port forwarding and stuff. You can treat that natted WAN as a WAN, but it's going to be it's going to be one-way traffic. Now, the cool thing you can do with this is you can also NAT to a VLAN that's public IP addresses. So if I have a /24 public IP range on the LAN of my B5000, I can NAT you to that. That SpeedFusion shows up as a WAN, and now you have a public IP address, no matter what internet you're using, that you can use for port forwarding or inbound connectivity on your local router. So NATing is kind of cool. It gives you some features, and you can select the VLAN that you want to NAT to. So if I had a public IP address VLAN, I could say NAT mode, public IP address, click on that, and literally you'd have a public IP when you connect.
Yeah, so if you were connecting it to a third-party SD-WAN, for example, that's how
yes.
you do that.
So now imagine, remember I talked about that 4500 and 32015 UDP and TCP. So here's where you can configure. The default is 4500 and 32015, but if you need to change that, you can say 4501, sorry, 4501 and 32015 if you wanted to. So nope, 4501, sorry. So you can say 4501 and I cannot type today. 4501, and then you can say TCP or UDP, or just leave it default and say UDP or TCP. Now, why would you want to switch between UDP and TCP? I have had scenarios where carriers will throttle UDP traffic, and hence the SpeedFusion tunnel just gets bogged down. I've even seen where application firewalls, like application-aware firewalls, at some of our hospital customers were being throttled by UDP. And when I switched over to TCP, they were not being throttled anymore. So sometimes UDP is not reliable or isn't solving the mission. And so you can switch to TCP. Now, you would say, well, why don't we just always use TCP? Well, there's a cost to that, right? You have retransmits, you have a little extra overhead related to TCP. TCP isn't as fast as UDP. So you're sacrificing a little bit of speed and bandwidth for reliability. And so if you're going for pure performance, UDP is usually going to work. Then you have bonding and dynamic weighted bonding. Dynamic weighted bonding has been out since 8.3 firmware, and that allows basically it optimizes bonding for variable speed WANs. So cellular, Starlink, things like that, where you're not always getting 100 by 10 or 1000 by 50. It could vary. And so what it does is it monitors packet loss, jitter, and latency as a means to detect congestion or limits. So it's going to use more and more bandwidth. Start you have 10, 15, 20, 25, 30, and it's going to use a little bit more bandwidth as it ramps up, and then it's going to start seeing the packet loss or the spikes in latency, and then it's going to tone it back down. So assuming that the latency, whenever you push beyond your WAN's allowed capacity, like if you had a 1 gig Ethernet and you try to push 1.5 gigs, you're going to see tons of latency and packet loss because the data can't get there. That same theory applies here. So it's pushing those boundaries, making sure that the throughput's there. Then you have link failure detection time. So depending on how fast you need to detect the links, WAN smoothing, which we talked about, TCP ramp up. When you turn that on, it turns off WAN smoothing. That's going to basically add WAN smoothing for the first 5 seconds. So basically, it's going to trick the traffic into going as fast as it can, then turn it off, hoping to basically imagine like a starter engine on a starter motor on an engine. It's getting it ramped up, hoping to push more bandwidth. And for a long time, that was the really good way to do it. Now we have SpeedFusion Boost. So SpeedFusion Boost is going to give us our it attempts to improve throughput on interconnection with packet loss and high latency. So your 5G circuits and your LEO technologies, and the idea is to improve links. And we've done this. We've had 2 webinars about this, so I won't go too much into it. But we've even seen improvements on single cellular and single Starlink connections related to SpeedFusion Boost, and so we've been pretty happy with that.
Yeah, SpeedFusion Boost is just making the uplink side
Yeah,
massive. I mean, it beats single link Starlink, right? If you have just a single Starlink plugged into your PC, you're going to get better performance running it through SpeedFusion on the uplink, which sounds magical, but it's real.
It sounds crazy, but we've seen. I mean, with the exception of my embarrassment 2 weeks ago or last month, we've seen some pretty good connections there. The forward error correction, once again, adaptive, low and high. We talked about that already. And then layer 2 bridging. When you turn this on, it's going to layer 2 bridge those two that connection, this tunnel. That means that the 2 routers will be their LANs will be interconnected. And so as one LAN. And so it's important that one, you know where your hub is and what your routers, and so you can see your hub site. Don't override your input. You can say as none or DHCP. And then but this allows you to basically create one massive layer 2 network. When you check this box, it'll also bond all VLANs that are trunked up to it. So this is not just for the untagged LAN or the root VLAN that's built into the router, but it's like taking a cable and plugging it in. It's going to connect those VLANs together for you.
Yeah, this is another way we see people using third-party routing platforms with Peplink. Instead of doing it an internet-based tunnel, they're using this as like a separate private link. So we see like ISPs that have, multiple fiber paths. They'll use a bonded array of Starlink and 5G as another path, and they just use layer 2 SpeedFusion to let them see the other router on the other side, just like if it were a fiber circuit. And, it's not the preferred path, but it's right there, and they don't know that it's actually 5 different connections. But yeah, there's that layer 2 is great for IoT too. There's just a lot of different ways people use layer 2 SpeedFusion.
And you can do this 2 different ways that I'm going to show you, by the way.
Cool.
The layer 2 portion of it. So then you have your path cost, your max latency differential. So once again, max latency, if you have a mission critical application that you want to keep the latency really, really low, you're going to say, hey, I want my max latency differential to be 50 milliseconds. And literally anything, if you have 2 circuits going and you're at 100, 80, 90, 100 milliseconds, and then WAN 2 is now at 160 milliseconds, at a 50 millisecond, it'll just stop using it. You'll see it go to kilobits. And that's because the latency is more than 50 milliseconds off of the other one. The default, by the way, is 500 milliseconds. But you can set your latency differential there. Upload SpeedFusion limit. Now, if you think about this, we're creating a tunnel. This is really, really important, and it messes people up all the time. Upload bandwidth. If I'm creating a tunnel between 2 sites, why is there not a download speed limit? Because the upload of the other side is the download of your side. So if I limit this to 10 megabits per second, the upload of the hub is 10 megabits per second. The upload of the remote site is 10 megabits per second. And so I have a 10 meg by 10 meg circuit going between these 2. So you only need to worry about the upload or uplink settings, because the downlink is going to be set by the uplink of the other side.
Yep, it's a pair, it's a tunnel. So there's an A and a B.
Yep. This use DF flag. So the use DF flag, we had an issue during COVID, and everybody was rushing out in the communities to try to set up these pop-up clinics and pop-up sites, and they were plugging Cisco APs into Peplink routers, trying to just basically emergency expand their network. And they would see like the Cisco APs would connect, register, download, and then just whoop, go offline. And we're like, what the heck? They were basically, there's a do not fragment flag in the Cisco configuration. And so it was blocking the traffic because the Peplink router was basically, it couldn't fragment. So it was just dropping the traffic. So we created a special firmware that basically just ignored the DF flag to allow that traffic to fragment and go over the tunnel, over to their data center and fix the stuff. It worked amazingly. All the Cisco APs came online. And then we added this. So if you want to make sure that your route support the DF flag, do not fragment flag, you want to check that box. But otherwise, never turn that on. That's strictly for allowing a DF flag to pass through the tunnel. Okay, so this particular assignment is actually about subtunnels. And so we created this whole thing, and now we got to create the subtunnels. So there's two options here, and they're not visible unless you click advanced. You see no advanced, this is what you get. I mean, that's it, right? Bonding, ports, and then regular settings here. When I turn on advanced mode, you get all this other stuff. Advanced link settings lets me configure upload on both sides. So I get to see both sides of the tunnel, and I can click this little plus sign and make additional tunnels. So here's my primary tunnel, and I can call this hot failover. Oh, link name, cancel. I did the wrong area there. Boom. Okay, so I can say hot failover. And then I can make a new tunnel, and I can call it WAN smoothing. So now that I have hot failover and WAN smoothing, my WAN smoothing here, I can come in here and I can turn on SpeedFusion Boost, and I can turn on WAN smoothing, normal, WAN smoothing. Once again, this is the uplink of this side and the uplink of this side making WAN smoothing. So I could, like, if I don't want the uplink to be WAN smoothed on this side, I could just say profile default or off. So it depends on what you want it to be. So I'm going to make it WAN smoothing, and there we go. And then enable my SpeedFusion Boost. On this one, I'm going to leave it alone because we actually don't configure hot failover in this area. So we'll just leave it alone, profile defaults. And then I hit save and okay. And then I can hit save. Now I can go to my WAN settings, advanced WAN settings. And in my WAN settings, now look, I got 4 tunnels here. The bottom to the top for WAN smoothing, the top to the bottom, and the top to the bottom for WAN smoothing. So I can select all these profiles and hit modify WAN settings. So for hot failover, I want to make sure I use my Ethernet WANs and then fail over to my cellular. So I can say cellular is priority 2. And let's see here. This one's bottom. Okay, so yeah, that one just has WAN 1 and cellular. So WAN 1, 2, and then the bottom one, 1, and then I should have my synergy. Oh no, this is bottom. Okay, and then this is my WAN smoothing, which I want to be all of them. And then top to bottom. The naming on this was really bad. I apologize. So now top to bottom. So WAN and then cellular is going to be 2. This is my hot failover. So WAN 1 is going to be priority 1. Cellular is going to be priority 2. And I should have Starlink, which will be priority 2. And cellular synergy mode is going to be priority 2. So what I've done is I'm saying the hot failover is going to use my Ethernet WAN. And then if it fails, it's going to bond my 2 cellulars and my Starlink together. That's my hot failover. My WAN smoothing is going to bond all of them together all the time. Does that make sense? And so now the other thing that's really interesting that is strictly GUI based is you actually have this ability to say disabled. Disabled, when you create these tunnels, and I'm going to do it like this to show you, but when you create these tunnels, you're going to have the ability, you're going to see all these WANs, and it makes the SpeedFusion profile a whole bunch of red. What I like to do when I'm doing these is I will disable any WAN. Like this bottom to top, the bottom router has no, I'm going to do one of them for you. I'm only going to do one though. Has none of these internets. None of these are working. So I can turn off all of these on this. I'm only going to do it on this one just to show you what it looks like. So I'm saying from bottom to top, you can use WAN 1 and then hot failover to cellular, and the rest of them are disabled. When I save this profile, you're going to see that the profile is going to look super clean. Green, yellow, boom, done. Now, I've already said this previously. Check the advanced box. Look, boom, look at all these extra features you're getting. So now we have a couple more features. We have WAN direction, up and down, and then you can do up only and down only. Why would you want to do that? One really good example. Let's say I've got 4 T-Mobile SIM cards, just as an example. And 2 of them are connected on band 41 and 2 of them are connected on band 25. So you have 2 on the exact same frequency on twice. I could say cellular 1, band 41 is uplink. Cellular 2, band 41 is dedicated to downlink. Cellular 3, band 25 is dedicated to uplink. Cellular 4, band 25 is dedicated to downlink. And I can actually have an entire cellular modem dedicated strictly to uplink and downlink, especially when I'm sharing the same frequency. So band 41, one modem is transmit and one modem is receive. And that's sometimes can improve capacity, especially when you're mixing frequencies.
Yeah, it
And
just
so
makes your efficiency way better when you're in those crowded scenarios.
Yep. Then you have this remote WAN, and here you can select the remote WAN. So if you like, for example, let's say you're on Comcast fiber, and you've got 10 sites that are all Comcast fiber. You could tell your Comcast fiber to only talk to Comcast fiber, and then that way you're going to maintain that lowest latency connection between those circuits. Now, I don't use it for that. I use it for private 5G and for private networking, so MPLS. We talked earlier about that MPLS where you use a private IP address. If my WAN 1 on all my routers is my MPLS network, I want WAN 1 to only talk to WAN 1 because that's on a private network. And so I would say WAN 1 to WAN 1, and then those 2 connections are only going to work like that. And so WAN 1 isn't going to try to talk to the cellular. It can't. So it makes it a much cleaner network. And if I say WAN 1 only talks to WAN 1, when the cellular connection is trying to talk back, even though it's on all, on the remote side, if WAN 1 is there, it's literally going to ignore that one because that one is said to only talk to WAN 1. So I don't need to be able to select multiple WANs here. By restricting WAN 1, these other WANs will automatically not talk back to WAN 1. And so it allows you to limit that. But it's great for private networks where you need those to connect without going to the internet. Or like I said, public networks where you want to like maintain lowest latency connectivity. Cutoff latency is different than latency differential. Cutoff latency is the maximum allowed latency for this particular circuit. We do this a lot in sporting events. We try to maintain, sub 30 millisecond latency. So if we have a whole bunch of SIM cards connected and they're connecting to different towers and frequencies, we'll say, hey, I'm going to set a cutoff latency of 50 milliseconds. I'm basically going to say at 50 milliseconds, stop using that circuit. Because most likely as I'm moving, I'm driving away from that circuit, and then I'm already on another one. And so I'm driving away, connecting, and then connecting this other one. And so my latency as I get further away from this tower is going to spike. And then especially when it's disconnecting and reconnecting to another one. And even though that's in the like milliseconds that it does that, you can get these spikes in latency as you get further away from the tower. And so a lot of times if you're trying to like maintain super low latency, having an actual cut off latency, not a differential, is really important. Suspension after packet loss. This says, hey, I want you, if you detect packet loss, just stop using that circuit for a couple seconds. And it's in the milliseconds. So you could say suspend for 500 milliseconds or for 5,000 milliseconds, right? And so you can tell it to suspend those circuits. Someone just asked about virtual network mapping. That's separate, and I can show you that once I get through this. And so you have these extra features. So I'm going to go ahead and save now, and now I can hit close. So I've configured I configured my tunnel, I configured my link settings, I configured my WAN settings. I can click next, finish, and save. So now I've created this tunnel. So I should be able to go to my router, and the tunnels should show up here in a few seconds. So let's see if they do. There they are. So there's my B1 bottom hot failover and my B1 bottom WAN smoothing. And so we'll wait for those to establish. And then I'll show you the... Someone asked about virtual network mapping. That is done on the router, or actually could be done in control. So I'm going to show you in control first. So virtual network mapping. Let's say I have 10,000 robots, and those robots are all 192.168.50.1, and they have controllers and different devices in them, and it's just logically like unscalable to log in and have every single robot with its own subnet on the router, on the unit. However, I want to be able to have two-way communication. So I want them to be their own isolated bucket. And we even had that where, like, I could take parts out of one device and put it in another one because the IP is the same. If the camera is always 192.168.50.3, well, that camera can be installed anywhere, and 192.168.50.3 will work. So it works really nice. We actually did it for a security system. We have a security VLAN, and that security VLAN, the controllers are always the same IP, and all the sensors are the same IP. But if we want to log in to configure those, we want to make sure that we can access those. And so there's something called virtual network mapping. So if you go into our LAN network settings, I'll show you this both areas. You can add a profile, and I could call this bottom. And I could say apply this to with any of the following tags, bottom. And then I can go to virtual network mapping, manage it, and I could put in a name. So now this does not apply right now because we have unique IPs. But let's just say you have 192.168.50.0 /24. And I could say it's a one-to-one or a one-to-many. And I could do a one-to-one map mapping to 10.254.50.0/24. And so what I'm doing is I'm saying for every 50 IP address, it now becomes 10.254.50. Or a cool way I could do this is 50 and then the first robot's .1, right? And then .2 and then .3 and then .4 and then .5. And so the first robot, the bottom here is going to be 10.50.1, and then the top one could be 10.50.2, and then the next robot could 10.50.3. And so I'd be able to separate these out this way. In SpeedFusion, if I create that tunnel, instead of seeing 192.168.50 in your address list in your OSPF, you're going to see 10.50.1. So you can have 1,000 sites with 192.168.50 networks and uniquely identified. Now, one thing to say is you need to create a profile for every single one of these. So you'll need to do this for every one of those robots. You can either do it locally in control right here, or in the router, you can go to network and virtual network mapping, one-to-one and many-to-one. Many-to-one works very similar. I can do this, and then I can just do 10.50.2, .1.2. And so what it's going to do is it's going to make all of this network look like 10.50.1.2. So they're going to be natted that way. So that's a mini to one, or you can do a one-to-one NAT mapping. And so it's a great way, like I said, especially in AI and robotics, industrial automation, things like that, where you want to have the same IP address on the LAN of every router, you can just do it that way. Okay, so now if I go to my status, so you can see, so here's my hot failover and my bonding. So look at this, my hot failover, I've got WAN 1 is connected, and then I've got this. So, and then you see this says routing outbound policy. So my primary tunnel will use OSPF between my sites. So it's going to know. So my primary tunnel will always be the one that uses OSPF here. Every subtunnel, and you have 5, by the way, every subtunnel is going to be routed by policy. So you have to create a policy to use that traffic. But you see how I've got WAN 1 as green, and then these are yellow, and then these WAN 1, all of them are green. If I go back to my dashboard and I move Starlink to priority 2 and go back to the status here, look, Starlink is yellow now. So this is really important. I've had customers complain about the failover time. It's not hot failover. It's not fast. If the WAN priority in the router overrides the Starlink priority, the SpeedFusion priority. So if this router is, look at this, cold standby and no IP address, right, it's in cold standby. So this device, if those 3 internet connections were to fail, that interface needs to activate, get an IP address, validate its connectivity, pass the health check, establish a tunnel, enable the routing, and then start working. So what I like to do is have all of my connections that are involved in these tunnels active. The only reason I will not is if they're cost prohibitive. Let's say I have a tertiary backup circuit that costs me $18 a gigabyte to operate. Maybe 15 seconds of downtime is worth the cost of the monthly just to have that as a tertiary backup, right? But I can use outbound policy to control the flow of this traffic. Someone asked a really good question, and I'll answer that too. So if I've got these all active, I can use outbound policy to now control the flow of this traffic. So I'm gonna go back to in control. I'm gonna go to outbound policy. So by default, the router is going to just load balance those 4 internet connections. So every session is going to get load balanced across those 4. Then it's going to use OSPF. So the first thing it's going to do is use OSPF. So what it's going to do is it's going to come in here and say, hey, I've got this 192.168.101 and 10.2.101. So if my destination is 192.168.101 or 10.2.101, I'm going to, by default, go with that. I don't have to tell the router to use that tunnel. That's in OSPF. It's being advertised among all my sites. That traffic will, by default, work as soon as you create the tunnel. You don't need any outbound policies. You don't need anything. However, I might want to control how those other connections are used. So I could say there's a couple things I can do, especially with this hot failover. So if I go to my outbound policies, I can add a rule that says hot failover. And I could say any source, any destination, any source, any destination, priority, hot failover. And I could drag all these off of here, which, by the way, Travis, if there was any way to like ask Peplink.
That is tedious when you start getting into the big boxes.
Yeah. My B5000 has 80 VWANs. Just scrolling them is a nightmare. Now you ask why I'm doing this, and I'll make it really cool. So I could enforce traffic. I could say any enforced and choose hot failover. However, that actually I don't like as much, and I'll tell you why. If I say hot failover, any priority, and only have the hot failover here, I get these 2 options down here at the bottom. When no connections are available, fail through the next rule. So if that SpeedFusion tunnel isn't up, fail through, just go get to the internet. So when no connections are available, fail through the next rule, and then terminate sessions on connection recovery. So when the router boots up, the tunnel's not going to be there. You might be load balancing traffic. Then it's going to follow this next rule. As soon as the SpeedFusion tunnel is up, it's going to terminate those sessions and connect to them appropriately. And so that's a great feature there. And basically this enables that hot failover for all of your network traffic. So you could say, now I'm saying if my source is anything and my destination is anything, and so that's where we're at. And then so then I could say for WAN smoothing, I could say voice traffic. And I could say if the source is my network 10.2.101.0, oops, sorry, network, destination any, and I could do the same thing, priority connection to hot failover. Or because it's a VPN, I could say enforced over WAN smoothing. So I'm saying if the source is my phones, which talks to a server at the other side, force it over WAN smoothing. This is going to make sure that my voice network is using WAN smoothing. Now, there are a lot, we're running short on time, so there's a lot of ways we can do this. You can do it by just protocol, TCP, UDP, IP, DSCP. You can do it by destination IP address. So if my phone server is 10.2.102.25, I could do it that way. Hey, if the destination is my phone server, do WAN smoothing. Now we talked about like Teams calls and Zoom calls. In control gives us database driven outbound policies. So I can create the rule, same rule, add policy, and I could say hot failover. And here I can say source any, destination any, protocol any, priority, SpeedFusion Connect, and then hot failover. So here I can say the same thing, but all I do is go source any, destination any, priority, hot failover, fail through, and terminate sessions. Boom, done. Then I can add a rule, and I could say meetings, and I could say source any, destination SAS, and here I could say FaceTime, Google Meet, Microsoft Teams, WebEx, Zoom, Zoom for government. And so the protocol any, and then once again, I could say, priority, SpeedFusion Connect with a tunnel, bottom, and WAN smoothing. And then once again, fail through the next rule and terminate on recovery. So now I can add, so my FaceTime, Google Meet, Teams, WebEx, Zoom, etc. is going to go over WAN smoothing. All my other traffic is going to go over hot failover. And then I could still add that source and that destination IP address, 10.2.102.25, and do the same thing. So I could add that IP address as well. And we are way out of time, but so we create the tunnels. The important thing is interface priority, how we have the interfaces up. Then we have the tunnels. We create the tunnels. The first tunnel will advertise via OSPF. Every additional subtunnel is routed by policy. And then we use outbound policies to control the flow of that traffic. And so when we're creating our tunnels, we need to create the tunnels, but we need to have a design. I always tell my employees, say, whenever we're talking about a network, we need to make sure we draw the network, draw what it's supposed to do. Make sure you know your IPs and the flows and conflicts, because those things all matter. I super hope you found this enjoyable. Someone asked, can you please mention the highest uplink and downlink that's been achieved? I have achieved over 30 gigabits of throughput. We've done, I've seen bonded Starlink. I believe we saw one at 1.6 gigabits over traditional, right? 1.47 gigabits per second over Starlink. I've done 30 gigabit, and I've seen in the upwards of 8 gigabits per second over Starlink, but we can't really talk about that one. And then but what we've seen on regular like Starlinks, we've seen around like 1.4, 1.5 gigabits per second with a lot of Starlinks and a powerful router like a B2500 EC or B5000. And then, but the throughput of your capacity is based on latency, jitter, and the quality of the aggregate of your WANs. And that is super important when you're thinking about bonding and capacity and throughput. But the routers can handle it. It's whether or not the WANs support it and then what you're trying to accomplish. SpeedFusion Boost helps this dramatically. Upgrading your firmware, upgrading your cellular firmware, having the latest carrier aggregation technologies on your 5G, having a 5G K chipset. I mean, and you got to think about it. The BR1 Pro 5G has been around for almost a decade. And you started with the GLTE, went to the 5G-D, went to the 5G-H, went to the 5G-N, went to the 5G-K. So not all BR1 Pro 5Gs are created equal. And so you can look at your product number and you'll see on the router, if I log into this, I should be able to hit show all right there, B1 5G-N. So this B1 is a 5G-N chipset. And so you could have a 5G-D, 5G-H, 5G-N, 5G-K, or some other 5G, or a GLTE, which is actually 4G, but 4x4 MIMO, which is kind of confusing sometimes. So, but not all of them are created equal. And then the only last thing I'd say about SpeedFusion performance is look at the spec of your router, but then the type of traffic you're handling. The spec and test of the router is based on optimal tested scenarios, and variability of capacity matters. And so what the health of those WANs, the traffic, and one of the things I wanted to do, which I just don't have enough time, is show you WAN analysis and bonding. So the next video we'll get into WAN analysis and bonding and calculations on that. That's what I wanted to do. So we'll do that next time. But thank you everybody so much for your time. I've really enjoyed this particular session, and hopefully we can just continue this series and then end up at the summit. If you like this content, we have created a website, connectivity101.com. I've got tons of training. I've pulled together over 300 videos that are online. I have all the user guides, data sheets, networking products, SpeedFusion. I've got all of the find a router, so all the routers and what their specs are. And I'm trying to keep this up to date. So if you're trying to understand or learn more, let me know. If you have questions, please send me an email. But like you can go to like InControl Zero Touch. We have step-by-step guides on it and then related videos. And so you'll be able to watch that. And I'm pulling videos from YouTube and Peplink University and everything that we have. So if you want to look at connectivity101.com. And then if you like this content a lot, we do have the summit, peplinksummit.com. This year it's in San Antonio, Texas. I am teaching a 4-day, well, actually, Travis and I are teaching a 4-day course. I mean, our throats are going to be shot. So, we love whiskey. And so you could just bring us a cup at the end of the day to help us soothe our throats. But 4 days of intensive training going over Zero Touch and SpeedFusion. And that's this November in San Antonio, Texas. We have sold out every single year. We intend to be sold out this year already. So if you like this content and want to learn more, please join us. We'd love to meet you. You can meet Travis and I, ask us questions, go through scenarios, and really play around with this technology in a community of people that love what's here. So if you like these videos, come join us, and we would love to see you there.
Yeah, go to the summit, please. If you haven't been, if you've been watching these videos, just come and check it out. It's such a vibe. Like there's just such a buzz for 4 days. It's just full on energy, and it's awesome. And yeah,
And
Peter,
we're gonna
you
have
did such a
10
good job
Starlinks on
building
the
that.
roof, OneWebs, 5Gs, private 5G. We've got workshops, labs, and enough time to actually go through these things and sit down and talk about it. So,
There
please.
are there are some presentations from names so big that I am not allowed to say. So like come and see it for yourself. Seeing is believing. Listen to what these people, these are industry experts at the biggest companies, and they're going to talk about how they're doing this and what they're doing. And so, yeah, for so many reasons, come check out the summit.
And then if you have any questions, please email us, peter@westnetworks.com or travis@peplink.com. And like I said, we'll continue next week, and we'll continue this series, and we'll make this a multi-part series until all the questions are answered. There's a lot here, so we'll just keep going through it. Thank you so much, and have a great day. Thank you, Travis.
Thanks.